Okay, so let's go over this study guide. Number one, this is just an example of the distributive property. So you'd have to distribute the number on the outside to each of the addends, each of the numbers on the inside. So that would just be negative 2/3 times 5 6x. And then we have a negative times a negative here, so that'll change that to plus 2/3 times, we have to change this whole number to a fraction, 3/1, which if you solve this, just go straight across, you get negative 10 over 18 plus 6/3. And that would obviously, I'm sorry, I forgot my x. That would be negative 10 over 18x plus 6/3. And we could obviously simplify that. We could divide both 10 and 18 by 2. So that would change that to negative 5/9. And we could divide and we could divide both 6 and 3 by 3. So that would be plus 2. That's your answer for your first one. Okay, let's move on to this one right over here, number 2. So here we have 3c, and again we need to use distributive property. I forgot to mention number 1, we wouldn't be able to simplify this. Here we have a term that has a variable of x, and here we have a constant, so we wouldn't be able to simplify it. Number 2, 3c times 5a would just be 15ac. Then we have 3c times 2b, so that would just be 6bc. And we have positive 3c times a negative 1, a positive times a negative, different signs. We're going to end up with a negative 3c. We have AC here, BC here, and C. So none of the terms contain the same variables. Okay, yeah, this one has an A. Yeah, this one has a C, and so does this. But remember, they have to have the same, all the variables have to be the same. So in order for us to combine these terms, they would have to have an A and a C that were the same. So let's go on to number 3. So if it helps, just do it the way we did in class and box around the like terms. Make sure you include the negatives, and then place a circle around the constants. So we'll be adding 5x plus 7x. They have the same variable raised to the same exponent, so we're adding them. 5x plus a negative 7x. We're adding integers with different signs, so we subtract their absolute values. 7 minus 5 is 2. And then this absolute value would be bigger, and that happened to have a negative, so it would be a negative 2x. Then this would be negative 4 plus 14, adding integers with different signs, which means we subtract their absolute values. 14 minus 4 is 10, and that right there would be the bigger absolute value, so we'd have plus 10. Let's move on to number 4. Again, go ahead and we have a constant here. You notice we have another constant over here. Here we have a negative 5x. Okay, here we have an 8x. And here we have a negative 5y. Here we have a positive 7y. So our two constants, we have negative 3 and positive 8. Negative 3 plus 8 will be 5. We have negative 5x plus 8x. Negative 5x plus 8x would be 3x. And then we have and you can go ahead and cross these out as you're doing them, if that helps you. And then we have a negative 5y and plus 7y, and that would be, that would be 2y, positive 2y. And normally we like having the variables first, so just remember addition is commutative. You can move things around. It would be 3x plus 2y plus 5. Either answer is correct. That's it. Number 5. Again, just box around the ones with the same variables raised to the same exponent. It must be raised to the same exponent. So here we have 4 x squared y. So we would only be able to combine this term with any term that has an x squared y. It has to have an x squared y, which we only have one term here that has an x squared y, which is this positive 5x squared y. Now, here we have a plus 2xy. So we'd only be able to combine this term with other terms that have an x and a y, both raised to the first power, which would be this negative 8xy. Then we have our constant here, negative 6, and we have another constant there, 13. So if we go ahead and add these, we have 4x squared y plus 5x squared y. Remember, we just add their coefficients. It would just be 4 plus 5. 4 plus 5 is 9x squared y. And we could cross these out. We're done with these. Then we have 2xy minus 8xy. Or you could think of this as 2xy plus negative 8xy. Adding integers with different signs, so we're going to subtract, right? 8 minus 2 is 6. And the negative 8 would have the bigger absolute value, so we'd have a negative 6xy. And then over here we have negative 6 plus 13. Again, we're adding integers with different signs, so we subtract 13 minus 6 is 7. And that would have the bigger absolute value, so it would have a positive 7 there. That would be your answer. Simplified. Number 6. So before we could simplify this expression, we'd have to use the distributive property. We distribute the 2 to each of the addends. That would just be 2x. Then we have 2 times negative 1. So it would be a negative 2. And then we distribute this positive 5 to each of these addends over here. So that would be plus 5x. And then 5 times 9 is 45. So what would we do next? We would box around our like terms, put some geometric figures around it. We have 2 positive here, and then 2 constants, one of them being a negative. So we have 2x plus 5x, that's 7x. And then we have negative 2 plus 45. So again, integers with different signs, we subtract and keep the sign of the integer with the higher absolute value. That would be 7x plus 43. Number 7, again, this is another one we'd have to use the distributive property first. So that would be 3x plus 18. I'm sorry, not 18, 27. And then here, we have a negative sign here. So you could think of this as minus 1 if it helps you. It's not much. Well, you remember you need to distribute this negative 2. So you could think of it as, hey, we're multiplying each of these addends by a negative 1, if that helps you. Or just by a negative. So negative 1 times x would be just negative x. And then negative times negative 6. A negative and a negative would give us a positive 6. Then we just combine like terms. So we have 3x here and negative x here. That would give us a 2x. We have positive 27 minus 6. I'm sorry, plus 6. No, it's not minus 6. That would be plus 33. That looked like a minus when I put the circle around it, but it was actually a plus. So it would be 2x plus 33. I have to distribute first to all of the addends, all 3 addends. So we have 15x plus 27. And then we have positive 3 times negative 4x. So that would be a negative 12x. Only 2 like terms here. So 15x minus 12x would be 3x plus 27. Would be your final answer. And right over here we have a plus 3a minus 4 times 9 minus a. So we're gonna want to use the distributive property first. Remember, this is a negative 4. So negative 4 times positive 9 would be a negative 36. And then negative 4 times negative a would be a positive 4a. Oh, that's a weird looking 4. Combine like terms. We have an a here and a positive 4a here. We have a 3, negative 36. A plus 4a would be 5a. Adding integers with different signs, so we subtract. That would be 33. Be a negative 33 because the absolute value of negative 36 would be bigger than the absolute value of 3. And that would be your answer right here. I'm sorry, I just realized that I made an error because this was not plus 3, this was actually plus 3a. So this would actually change the problem. It would be a plus 3a, which is 4a, plus another 4a, so this is wrong, which would be 8a. I'm sorry, this should have a rectangle around it. I messed up here. See, I just put a 3 here. I apologize about that. That was a 3a. So it would be a plus 3a, which is 4a, plus another 4a, which is 8a, and then there was nothing here to go with 36 with the constant with the negative 36. It would just be 8a minus 36. I apologize for that mistake. And that's it for these problems. Let's take a look at number 10, perimeter. So remember, when you find the perimeter of a two-dimensional geometric shape, you're just adding all the sides. So that's, I'm sorry, you're just when you're finding the perimeter of a two-dimensional geometric shape, you're just adding all the sides. So this is just going to be 2x minus 5 plus, that's this side here, that's this side here, plus 5 minus x, that's that side there, plus 3x minus 2, which is that side there. And then you just combine like terms. So we go ahead and use our geometric shapes here. So we have 2x minus x, 3x, all of them have the same variable. And then we have our constants. So 2x minus x, it's 2. Remember, when you don't have a number in front of a variable, you could assume it's 1. So it's 2 minus 1, which would be 1. And then 1 plus 3 would be 4x. And we're done with all the x's. You can cross them out, put an x on them, whatever. Then we have negative 5 plus 5, opposite signs, so we subtract, that's just 0. And then 0 minus 2 would just be minus 2, negative 2. 4x minus 2 would be your answer. Okay, so let's get into translating expressions, equations, and inequalities. So here we have the product of a number and 4. Product of a number and 4. Product, remember, means multiplication. So this would just be 4 times n, or n times 4, or whatever variable you want to use. Number would be a key word there that means variable. So number 12, we have 5 times the difference of a number and 3. So this is going to be one of your parenthesis phrases. Okay, so we're multiplying 5 times what's in here, the difference of a number and 3. The difference of a number of 3 is what we're multiplying by 5. So the 5 is going to be outside, and we're multiplying. We have times here. So 5 times. And we're multiplying 5 times the difference. What does difference mean? Subtraction. So we're subtracting n, a number, and 3. There you go. And then last one, 7 less than. Remember, less than is going to mean something minus 7. Subtraction, reverse. So it's going to be something minus 7. What goes here? A number squared. A number variable squared. N squared minus 7. Now we're doing the same, just with equations. And how do we know we're dealing with equations? Is. So the first one, the quotient of a number and 2 increased by 9 is negative 15. Quotient of a number and 2 increased by 9 is negative 15. So is right here is going to tell us that we're dealing with an equation. And on the right hand side of the equation, that's easy. It's just a number, negative 15. Left hand side of the equation, the quotient of a number and 2 increased by 9. Let's focus on this side of the comma first. The quotient of a number and 2. Quotient is going to mean division. And what are we dividing? We're dividing n, a number, and 2. But then after that we are increasing by 9. Increased by 9, increased means add. We're adding 9. And that would be your expression. Next we have 1/4 of a number of means multiplication, minus 8 is negative 23. So again, we have is, so we know we're going to have an equal sign. The right-hand side of the equal sign is just going to be negative 23. Left-hand side of the equal sign, we have 1/4 of a number. Remember, of means multiplication. We're multiplying that by 1/4. 1/4 of a number n minus 8. So just minus 8. That's it. You don't have to solve these, just leave it like that. Now, some of your test questions you might be asked to solve them, but here you were just writing the algebraic equation. You're not asked to solve them, so you just leave it like this. And then number 16, the sum of twice a number in 6 is the same as 3 subtracted from the number itself. So here we're going to have an equation where we have two expressions that are going to be equal to one another. We have the left-hand side expression and the right-hand side of the equation's expression. Let's focus on the left-hand side first. We have the sum of twice a number. So we're adding something. What are we adding? We're adding twice a number in 6. So this plus this. Well, what is this? Twice a number, that means 2 times n. And we're adding that with 6. That's sum. Sum, remember, means addition. Now, what does that equal? That equals 3 subtracted from the number itself. Oh, and I should probably put this around from. So remember, subtracted from means subtraction in reverse, just like less than. So it's going to be something minus 3. What is that something? The number itself. So we have to use the same variable since we're talking about the same number. And the variable that we used was n. So that would be n minus 3. Okay, and the last section here is inequalities. So here we have a number greater than negative 5. Greater than, remember in your notes, greater than is, what do you mean greater than? So we have the greater than inequality symbol. A number will be a variable n, and then we have that number is greater than negative 5. So that's it. N is greater than negative 5. N can be anything that's larger than negative 5. Next, we have a number that is at most 30. So remember, at most is going to be one of those words that might be confusing for some, but that's going to mean less than or equal to. A number n is less than or equal to 30. So just make a point to remembering that. N is less than or equal to 30 whenever you have at most, and at least we'll do that. Well, let's do it now. At least there's another one that sometimes confuses students. That's going to mean greater than or equal to. So a number that is at least 90 would be n is greater than or equal to 90. So you could think of it like in real world terms, if it helps you. For example, if you have to be at least 18 years of age to vote, that's obviously going to mean 18 or older, 18, 19, 20. You're not going to be 3 years old and vote. So, and then the last one, minimum number of 17. So minimum means that is our low point. So we have to be greater than or equal to 17. And is going to be greater than or equal to 17. That would be a minimum number of 17. And that's it. So if any of these troubled you, if even after this review video, if any of these troubled you, if any of these questions on the study guide troubled you, make sure you come to tutoring tomorrow at 8 in the morning, and I will be more than happy to do some more examples with you and go over them. I'll see you tomorrow.